Okay, I'd like to give some help on page 196, your homework. Somebody sent me an email about question number 12, so I'm going to show you how to do number 12. First thing you do, you notice I copied the problem. The directions say to identify all the double roots. To do that, you first have to get everything on one side of the equal sign and have the other side equal to 0. So I'm going to do that first. So let's put equal 0 here. The 27 has to move across the equal sign. It becomes a minus 27. So here's the new problem. Y to the third plus 6y squared minus 27y equals 0. Next step is factor. First type of factoring, common factor. Is there something that all three parts have in common? I hope you notice they have a y. So here it goes. Y, factor that out. When I take a y from y cubed, I get y squared left. Take a y from here, plus 6y. Take a y from there, minus 27. Close the parenthesis, equals 0. So I did a common factor. I look at this trinomial. I notice it probably can factor into two binomials. So I'm going to take a crack at it here. So let's get the two parentheses ready to go. First part's pretty easy. Y times y is y squared. No big deal. The negative 27's a little bit tricky. So I need to think about factors of negative 27. Negative 1 times 27. 1 times negative 27. 3 times minus 9. Minus 3 times 9. Those are all the possibilities that could go in these parentheses. Only one of those answers will work. I need to get a positive 6 in the middle. If I look at each group and try to add them, one of those groups adds up to positive 6. Do you know which one? All right, yeah, that's the one. So here, let's try that. Minus 3 plus 9. Now I do a little check in my head. I multiply these two, minus 3y, these two, plus 9y, add them up, plus 6y. Yeah, it checks, it works. So, now that I have it factored, the question said identify all the double roots, all roots and double roots. So, what are the roots of this? One quick thing is if the equation that you start with is of third degree, chances are you could have three roots. You could have three different roots, or you could have one root that's the same for all three parts, which could be a triple root, or you could have a double root. So, let's take our three factored parts, which is y minus 3, y plus 9 equals 0, and set each one of those parts equal to 0. Y equals 0. That's one solution. Y minus 3 equals 0. Solve that. Y equals 3. Y plus 9 equals 0. Solve that. Y equals negative 9. Those are the three answers to problem number 12. Now the rest of the problems in the set are similar to this. The tricky part is you need to get everything on one side of the equal sign, one part is equal to 0, and then you need to factor. Factoring rules. Try common factor first, then try different groups. Sometimes you have to do groups by twos. Sometimes you have to use the cube factoring rule. So, see what works, and good luck with the rest of your homework.